Today I wanted to talk to you about a cool feature of phase changes at the change point, so on this equilibrium line, and then also go through an example. So as you guys have probably seen in your chemistry class, this is a phase diagram which has pressure on the x-axis, temperature on the y-axis, and then it goes through and explains what the different state of the molecule will be in the different temperatures and pressures. Okay, so generally places are about 1 atm. And so this is a phase diagram for water. And when you have, low temperatures here, your water is going to be a solid, right? And so it's ice. And as you increase the temperature, so as we go along this x-axis, then our water becomes a liquid. And then as we increase that temperature, our water becomes a vapor or a gas. Okay, so these are the different regions of the phase diagram. We have solid, liquid, gas. And if we change the temperature or the pressure, the phase of the molecules that we have or the substance is going to change. So these phase diagrams are very dependent on what substance you're talking about. Okay, and so I want to talk to you about kind of the cool things that happen. And so over here is another graph, and here we're adding heat. Okay, and so this is kind of over time. So up here, we've got our temperature increase. And so as we increase the temperature, right, we're going to start as a solid. And so we have ice. Ice continues to happen until we hit a certain temperature. Okay, and so it's just like here, we have ice, we're increasing the temperature, right, until we hit a certain temperature. And then we start changing, right, from ice to water. And so something really cool happens when we hit that equilibrium line. And that's kind of demonstrated right here for this heat of fusion. The temperature doesn't change as that change happens. Okay, so I'll write that up here. Temperature does not change. So that little triangle is change while the intermolecular forces break in the solution, okay, or in the substance. And so this heat of fusion is for when we go from a solid to a liquid, we get a delta H value of fusion. Okay, so our temperature is not going to change as we sit at that line. Okay, and then pretty soon all of our ice is melted, and now we're in the water phase. Okay, maybe I'll change my color here. So now once we're in the water phase, right, we're going to continue heating the temperature. And so right here is where we continue to heat the temperature. Okay, so this is the liquid temperature increasing along that line. And then all of a sudden we hit that phase transition again. And at that phase transition, we have our heat of vaporization where we're going from a liquid to a gas. And that's called delta H of vaporization. And again, our temperature does not change as this transition happens, right? So for a transition to happen, the intermolecular forces between all the liquid molecules have to break to become a gas, okay? Then once again, we've gone through that transition and we're now in the gas phase. And here we have that gas phase as steam.